Let's recall what a percentile rank tells you. So, what does it mean to say a student scored in the 75th percentile on an exam? If a student scored in the 75th percentile on an exam, that means that 75% of students scored what he did or less, which then also means that 25% scored better. So percentiles are measures of position. We've already studied the measure of position known as standardized score. We now want to study another measure of position, which is percentiles, but three specific percentiles known as the quartiles. The quartiles are the 25th percentile, the 50th percentile, and the 75th percentile. And there's notation to go with each of those. The 25th percentile, also known as the first quartile, is known as Q1 or Q sub 1. The second quartile, which would also be known as the 50th percentile, is known as Q2. But I claim to you that we already studied the 50th percentile. What measure of central tendency, so there's overlap here between measures of position and measures of central tendency, what central tendency is the same thing as Q2, meaning it tells you the 50th percentile? Well, that's precisely the median. And finally, the third quartile, which is known as Q3 or Q sub 3, is precisely the 75th percentile. So we're not going to study percentiles in general. We're going to specifically look at the 25th percentile, the 50th percentile, and the 75th percentile. Now, a couple of things you want to notice here. With median, that's the very middle when things are put in order. We've already studied that. Then the idea of the first quartile is if you take the first half of the data and find the middle of that then is the first quartile. And if you take the second half of the data and find the middle of the second half of the data, that would then give you the third quartile. So we are essentially going to compute almost three medians of sorts. Let's look at an example. You may recall this data set we've used recently. It's the money spent on music per year among a bunch of students. Let's now find the 5-number summary of the following data. So the 5-number summary is defined as the three quartiles, Q1, Q2, and Q3, as well as the minimum value and the maximum value. This makes up the 5-number summary. So let's go ahead and answer this. Well, first, the minimum is 0, and the maximum is 689. I already have these numbers in order here in the table. Now, let's find the median, and technically we've done this with this data set, but the median is, well, you've got 10 here and 10 here, so the median is the average of those two numbers. And 200 plus 214, that quantity divided by 2 is 207. The new stuff is Q1 and Q3. Let me quickly erase these real quick. We first need to distinguish between the first half of the data and the second half of the data. So if you go through, this top part in white is the first half of the data. So this is the first half. And then in blue down here is the second half. We split it in two halves. Again, once the numbers are arranged in order, otherwise this is meaningless. Now, to get Q1, we need the median of the first half. So we're essentially just looking at this data set right here, pretending like the bottom part doesn't exist. We need the median of that, and the median of that is the average of these two numbers, because those two numbers sit in the middle. Well, the average of 70 and 85, you would do the sum of 70 and 85, and then divide by 2, which would then give you 77.5. Then to get Q3, which is the median of the second half data, so we're now only looking at the second half data, we need to get the middle of that. Well, again, there's 10 data points here, so there's not one point in the middle, there's two, precisely these two. We need to get the average of those. We would take the sum of 325 and 407 and then divide that sum by 2, which gives us 366. This is the 5-number summary of our data set, the money spent on music per year by 20 students. Let's now create a graph that specifically goes with this 5-number summary. It's called a box and whisker plot. Our 5-number summary had a minimum of 0, a Q1 of 77.5, a Q2 or median of 207, a Q3 of 366, and a maximum of 689. We are now going to make a special type of plot that specifically goes with a 5-number summary. It's called a box and whisker plot. Before we actually create the plot, we need to make a scale down here on our horizontal axis. Well, we go from 0 up to 689, so let's jump by 50s. We've got 0, 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, 650, 700. We don't need to go any higher since the highest number is 689. So let's write these in, and I'm going to stagger them just so there's enough room here. So 0, 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, 650, and 700. Make sure you have a consistent scale on this axis. Now, to create a 5-number summary, we are going to put dots at the minimum point and the maximum point, and we're going to put little vertical lines at Q1, Q2, and Q3. And I do generally tend to put the plot up above the axis so it doesn't get too messy. So we're going to put a minimum at 0, a dot there, and a maximum of 689. Again, we're going to approximate here. It's between the 650 and the 700, closer to the 700. And then vertical lines at Q1, Q2, Q3. So Q1 is 77.5, so right about here. Q2 is 207, pretty close to the 200. And 366 is Q3, 366 is about here. And now you'll see why it's called a box and whisker plot. With the 3 vertical lines, you create a box. And then from each of the sides of the box, you draw a line out to the dot, creating what looks like 2 whiskers. This is a box and whisker plot. Part of the value of a box and whisker plot is you can see where each 25% of the data is congregated. So the first 25% is here. Then the second is here. The third quarter of the data is here, and the final 4th quarter is located here. And often people want to know, what about the middle 50% of the data? Since the middle is what we would consider most common. So that's from here to here. We've got the middle 50% of the data is located in this region. Now, that middle 50% is so important that people have even defined a range that tells you the difference between this point and this point. It's called the interquartile range. And the interquartile range is precisely Q3 minus Q1. In general, that's the interquartile range. And for this specific problem, the interquartile range is 366 minus 77.5, which gives you 288.5. So the interquartile range for this data is 288.5. And what that tells you is the middle 50% of the data is within a range of $288.5 of each other. Because remember, this is dollars spent on music per year. The other thing that's really good about a box and whisker plot is that you can see skewness. So you've got 50% of the data located here, the middle 50%. The first quarter is really condensed. And then you've got this thing's really spread out. And the reason is because this point right here is extreme. This is what we would call an outlier. So if you've got one short whisker and then a really long one, the one in the direction of the long one tells you this point over here must be an outlier. And these 2 points actually are essentially outliers. They're significantly more than all these other values. So it can show skewness. So this has a long tail in this direction. So whatever the direction of the long whisker is, that's the direction of skewness. So this is a skewed right data set. Even without creating a histogram, we can see this.